Hello class, we're going to continue on with Java arrays right now. Last time we just kind of introduced ourselves to an array. Remember, this is the way we can make an array. I have array 1, it's going to be an integer array, and I'm going to initialize it with these values here, 2, 5, 8, and 9. And here I'm going to actually create a brand new array here, and this is an array of size 4, and in this case it's going to be all 0. Actually, let's visualize this for a second. So I'm going to draw this array here. It has a 2 and a 5 and an 8 and a 9 inside of it, and this is my array object, and I have my variable name array 1. That actually I'm going to draw it like this. It's actually a reference to that object. So that's the first line. And the second line, I'm going to make array 2. And it is a reference to another array object. And in this case, they're all 0. Okay, so this is my array 1, my array 2, and what I'm going to do, I'm going to do a little example of where I want to copy all of this information over here, and we're going to do it with a loop. We've learned how to do for loops, so let's do that. I'm going to create a variable called index, IDX. This is my loop variable. I'm going to start from 0 and then go to 1 and then 2 and then 3. Now, in Python, we would do something like this. The length of array 1. Well, we don't have that. Actually, length is not available to us, so we're going to do something else. What we can do instead is array.length. So this is what you have to know. It's not this for Python. It is this for Java. This gives us the same information. How big is my list? How big is my array? And then I want to increment my index every time through the loop. And every time, what do I want to do? I want to take this value in my array 1, and I want to then assign it into array 2. And in doing so, it will then copy this value over here. So the 2, 5, 8, and 9 will all be copied over. Okay, now, just a summary, array.length. Length is a instance variable of the object that indicates the number, the size of elements in the array. Now, notice that array2 equal array1 does not work. Does not work. Why not? Okay, let's actually take this picture up here. I'm going to actually bring it down here. And if I were to have done this, suppose I did these first 2 lines of code, which then results in this, and then I say array2 equals array1. So what happens when I say array2 gets, think of the equal as gets, array2 gets array1. Array2 gets a copy of this reference. This reference will be copied over here. So actually what happens is this reference will now be modified, and this reference will be gone. So this, whatever was in here, will get copied over here. So they then, array 1 and array 2 are aliases. They are 2 variables that point to the same object, which is not what we wanted to do. What we wanted to do was to create this whole new array that had all the new values inside of it instead. Okay? All right, there is an enhanced for loop in Java. It's a nice way of iterating. So if I say I want to add up all the numbers here in my array, I'm going to initialize a variable to total. I want to just iterate through every element here. So I could do the following. I could say for every value, I'm going to create a variable called value. It's going to be of type integer. And this colon here is like the Python in. Think of it this way. For every value in my array, take that value and add it to my total. So value gets 2, add the 2. Value gets 5, add the 5. Value gets 8, add the 8, etc., etc. So it's nice. This is actually very useful. We can do this with a variety of different things that we will see later on as well. Okay, switching topics. We're going to kind of talk about a number of different things today. We can pass parameters when we pass an array to another method or any other object. It's important to understand that what we're actually doing is that we're passing a reference to the object. And you could think of it as an address, you could think of it as a pointer, an arrow, however you want to visualize it. We're not actually passing the entire array. Consider this. If I had a huge array of size 1 million, it's a huge data array. I'm not actually copying that 100 words of data when I'm passing it to another function. That just would be almost ridiculous sounding to do. You wouldn't want to do that to make a copy of the entire object when I pass it to another function. That could be expensive and costly to do. And so it's actually true for all objects in Java. When an object is passed as a parameter to another function or method, we actually just merely pass a reference to that object, not the entire object itself. So, this is the example. I have my array here, and visualizing it, the way to visualize it, actually, let me correct this a little bit. I like to show it like this, where my array is actually a reference to the object over here. And I like to draw my objects like this. So my array object is here. My array is really a reference to the object itself. And so when we're passing the array to another method, we're passing this over here. We're passing the reference. We're not passing the actual object. So let's visualize that over here. And let's actually contrast that to passing a primitive data type. So I have two methods here. And in the first method, the input parameter is primitive data. In the next case, the input parameter is an object. It's an array. More strictly, it's an array reference. It's an array, okay? And I'm doing something very simple here, just setting the value x to 0 or y 0 to 0. And I'm going to then call this, and we'll see what happens. So let's visualize it. X equals 10, and I want to actually draw what that looks like. So in memory, I have my little piece of memory here, my name of this piece of memory, and I'm going to stick a 10 inside of it. That's primitive data. And then the second line, I have y is equal to this array 100, 200. Now it looks like this. I have my variable y, and it's this little block of memory, which is a reference to my actual object over here. Okay, now I'm going to call my first function make 0, and I'm going to supply x as my input. And when we do that, notice up here, there's this other integer x right here. And in this case, actually, let me back this up a little bit. X is my input here, which this x is my red x versus this x, which is my blue x here. This is a local variable called x, that just happens to be called x as well. But I use red here because it is a local variable to this method here. And so what I'm going to do when I feed in the value of x here, this value here, 10, gets copied up here. And then I say x equals 0, and this x again is the red x, my local x, and so this changes to a 0. And then I call my other function make array 0, and I'm going to call it again. So let's start off by kind of imagining that. So in a similar way, y is a reference. It's a little piece of memory that's going to reference an array. And so you can see here that this array y is passed to this. And when it is passed into this parameter, it is being copied in the same way that the number 10 is copied up here. I am copying this reference up here as well. But when I copy that reference, it actually points to the same object. So the copying is the same. You know, copy it up here, copy it up here. But in one case, I'm copying the actual information, the number 10, the primitive data. In this case, I'm copying the reference to the object. Okay, so now it says take y0 and set it to 0. So I'm going to look it over here. I'm going to look at the purple y. And element 0 is right here. And I'm going to modify that to 0. And then I return, and now I'm going to print out x. Now, in this case, this x is the x right here, which is right over here, and it's going to print out the value 10. And then when I print out the y0, this y right here is this one right here, which so happens to have changed because these were aliases to each other. This method up here was actually modifying this object here, which was shared between the two here. And so in this case, it's going to print out 0 and 200. So interesting the way the behavior is different between these two methods here. Okay, so hopefully this helps you understand what happens when we're passing an array to another method. We're actually copying the reference, not the entire array. Okay. Now, let's compare that to Python. In Python, everything is an object, even integers. And so in Python, it's the same concept as we see over here, where we're always passing references to that object. So now the difference is that in Python, everything is an object, and there are some objects in Python which are immutable and some which are mutable. This is a detail you don't really need to know too much about, but in Python, integers, so this is Python. Integers, I didn't spell that too well. Integers are immutable, they cannot change. Whereas in Java, primitive data like int, float, etc., they are mutable. And so there is going to be a difference when I pass integer objects in Python, which are immutable. The behavior changes a little bit. So in some sense, if I translated this all to Python code, the behavior would be exactly the same in terms of what gets printed out. It's very subtle why it's different, or why it is the same, even though we're passing objects up here as well. Again, this is maybe a little off topic. Maybe I don't know if I really even should have gone into that level of detail here. But yeah, in Python, everything was an object, and we always passed references to objects. Whereas in Java, sometimes we're passing primitive data and we're copying it over. Sometimes we're passing objects where we're actually copying references when we're passing it to another method. Okay, so that's the lesson today on Java Arrays Part 2. Okay.